All right, good afternoon, mathematicians. So in this video, I'm going to walk you through the filling and wrapping study guide that is in your workbooks, okay? In preparation for your test on Friday. Okay, so first thing is we're actually missing a dimension on this triangle here, or on this triangular prism, excuse me. And I want to make this an easier dimension. I want it to be a whole number. So those of you who are going to be critical of, of actual right angle or right triangle relationships, we're we're just going to say that this length is going to be 15. I know that may not be mathematically true, but we're just going to go with it for right now, okay? Just for the sake of having a whole number. So the first thing is we need to read all of this information that the problem gives us. So it says a movie theater sells 2 sizes of popcorn. One box has the shape of a triangular prism, popcorn T, and the other box has the shape of a rectangular prism, popcorn R. The boxes do have tops. The boxes do have tops. That is important. That's going to change our surface area. Okay. All right, let's take a look. It says how many square inches of cardboard surface are needed to make each box. So there are essentially 2 problems within this. So I'm going to work with popcorn T over here, so the triangular box over here, and then I'm going to work with popcorn R on the right side. And we're looking for surface area, right? Cardboard surface, that surface is underlined. It should give you a hint as to what we're trying to find here. So finding the surface area of my triangular prism, remember we're just finding the area of every face on the box, and we're just finding the area of every base, and then we're just adding them together. So the dimensions of this triangle are 10 by 8. Now to find the area of the triangle, we take 10, we multiply it by 8, and then we're going to divide by 2. So this is 80 divided by 2 is 40. So it looks like the area of the triangle is going to be 40. Now the next question I need you to ask yourself, well, how many triangle faces do I have? Well, I have 2 of them, so I'm going to be multiplying that by 2. So we have a total of 80 for the area of my 2 bases. Now we have a bunch of different rectangles here. So here's one face. I say that the dimensions of this are 5 by 10. Okay, so to find the area of this, we multiply 10 times 5 and we get 50. Okay, then I have another rectangle with the same height but slightly shorter. This is going to be a 5 by 8 rectangle, so the area is 8 times 5. So that's going to be 40. And then I have one more rectangle, and that's going to be on the very back side. So this highlighted in orange here. So this rectangle here, this is going to be my 5 by 15 rectangle. Okay, these are not drawn to scale. 5 times 10 is 50. 5 times 5 is 25. 50 plus 25 is 75. So the area of that final rectangle is going to be 75. I'm going to rewrite this so I can fit this last area here. Is 75. And then all we're going to do is we're going to add these together. It looks like I'm going to have 5 at the end, and then 7 plus 4 is 11, plus 5 is 16, plus 8 is 14. I mean, what am I talking about? 24? So it looks like my surface area of popcorn T, or the triangular prism, is 245 square inches. All right, and let's move over to popcorn R. So our dimensions are 2 by 6 by 9, right? So we did this version in class where we made the smiley face. So we have one set of faces that's 2 by 6, so one set of faces that's 6 by 9, and then one set of faces that is a 2 by 9. So we have 2 by 6, which is equal to 12. And I have two faces that have an area of 12, so I'm going to be multiplying that by 2 for a total of 24. I have one face that is 6 by 9, so that's 54, an area of 54. And then again, I have two of those faces, so I multiply that by 2 to get 108, and then my last face is a 2 by 9, so that's 18, and again, I have two of those. And so that is 36. And now all I do is add these together. So 6 plus 8 is 14, plus another 4 is 18. 3 plus 0 is 3, plus 2 is 5, plus 1 is 6. And then I have a 1 at the end. So there we go. So I have 168 square inches of cardboard for popcorn R versus 245 square inches for popcorn T. Okay, let's take a look at question number 2. So again, I'm going to split this into 2. Popcorn T is going to be on the right, or sorry, on the left, excuse me. Popcorn T, and then popcorn R is on the right. Okay, so popcorn T, to find the volume of this shape, what we're going to do is we're going to find the area of the base, which we already did, which is right here, our work that we did here. Okay, so we take 10 times 8, and then we divide it by 2. And then, after that, to find the volume, right, we take the area of the base and we multiply it by the height of the prism. The height of the prism is going to be here, and that's going to be 5 inches. So what you're going to do is you're going to take this, which is 40, and then you're going to multiply it by 5 for a total volume of 200 cubic centimeters. Do you need something, Alex?
I left my something.
What did you lose?
Pencil box.
I found one the other day, but I don't know if I don't think it's yours.
Oh no.
No, this is the only one I found.
Okay.
Did you check your other classes?
Yeah.
All of them already? Okay. Did you check your RAM class?
No.
Okay, go check there. I haven't seen anything. I'll keep my eye out for it though, okay? Alright, sorry about that, you guys. So we were finding the volume of popcorn T, which is about 200 cubic centimeters. Let's go ahead and find the volume of popcorn R. To find the volume of this rectangular prism, all you're going to do is multiply all three of your dimensions together. So 2 times 6 times 9. So 2 times 6 is 12. 12 times 9 is, is 108 cubic centimeters. And there we go. Excellent. Now, question number 3, it says, suppose the theater decides to sell a third popcorn size, the family size box. The family size box is a rectangular prism with a top. The scale factor from the rectangular box to the family size box is 2.5. So here is where we're going to use the formulas we created for scale factors, and figuring out what is a new surface area, what is a new volume. So for surface area, remember that we are going to take the surface area of our original figure, I'm going to say the surface area of the original figure. In this case, it's going to be popcorn R. We're going to multiply that by our scale factor. So scale factor a number of times, and you might remember that it's 2 times our scale factor squared, and this will give you the surface area of your new popcorn box. So that's exactly what we're going to do. So, and remember, we're only working with popcorn R here. So popcorn R's surface area was 168. We're going to multiply that by 2.5 twice, so 2.5 squared, in order to get the new surface area. So you're going to go ahead and type that into your calculator. I would do 2.5 squared first. So 2.5 squared is 6.25, and then you're going to multiply that by 168. So the surface area of the new box is going to be 1,050, and we are in inches, so square inches. Okay, and we have a very similar formula for the volume. Remember the volume, you start with the volume of your original, and you multiply that by the scale factor, not once, not twice, but 3 times in order to get your new volume. So we're working with 108 from Popcorn R. So 108, we're going to multiply that by 2.5 3 times in order to get our new volume. So I would start with 2.5 and cube it, please. So 2.5 to the third power is 15.625, and then you multiply that by 108 to get a new volume of 1,687.5, and now we are in cubic inches. I'm going crazy with my units. I thought we were in inches. Yes, we are in inches. That's a lot of inches. Okay. So all of these should be in inches, you guys. Inches. This should be inches. I'm in a centimeter kind of mood. There we go. Okay, cool. We're done with page 69. All right, on page 70, you're only going to do the first 4 problems. Okay, we haven't learned how to do this, right? The equation of the graph just yet. We will get to it, I promise. And I don't want you guys to worry about these last 2 either. Okay, so don't worry about any of these 4. Just do the first 4. So we're solving equations here a little bit more complicated than last time. So I need to simplify this side. What's negative 4x minus 6x? Well, negative 4 minus 6 gives me negative 10, and I just attach an x to it. Now, to get x by itself, I'm going to divide both sides by negative 10. Do not add 10, right? Negative 10 and x, they are attached to each other by multiplication. So you can't just add 10 to get rid of this negative 10. We have to divide by negative 10. Okay, so negative 20 divided by negative 10. A negative divided by a negative is a positive. So it's going to give me positive 2. And then the same thing on this side. I'm just left with x. So x is equal to 2. Let's move on to the next one. Here, whenever you see a number that's just lingering outside of parentheses, you're going to distribute. Use the distributive property here. Okay, and be mindful of the negative sign that is attached. So we're distributing a negative 4. So negative 4 times 1 gives me negative 4. Negative 4 times negative 6a gives me a positive 24a. And there we go. Now we can solve. So I like to get my variables on one side of the equal sign. So I'm going to subtract 24a. And you might be saying, oh my goodness, because now I have 0 a's. But I'm just going to continue solving like normal. 0 minus 22 is equal to negative 4, because these cancel each other out. And 0 minus 22 is just negative 22, and that is equal to negative 4. I think not. This is not true. So what we say here, whenever you have an equation that is not true, you're going to say no solution. All right, let's keep going. Again, there's a 2 outside waiting to get into the party, so we're going to distribute 2. So 2 times 4x is 8x. 2 times negative 3 is negative 6. And then now we can remove the parentheses. 4 plus 2x. There we go. Let's simplify a little bit. 8x, negative 6 minus 8 is negative 14. And that is equal to 4 plus 2x. Get your x's on one side and your constants on the other side. So I'm going to subtract 2x, so that's 6x minus 14 is equal to 4. I ran out of space, so I'm going to move over here to the left. You're going to add 14 to both sides. Ooh. So 6x is equal to 18. Divide both sides by 6. So you get a final answer of x equals 3. There we go. We got one more. All right. Get your variables to one side and your constants to the other. So I'm going to subtract 7x from both sides. So now I have x, or 1x, minus 2 is equal to negative 9. Add 2 to both sides. Negative 9 plus 2 is negative 7. And there we go. Awesome. Hopefully those are painful. I mean, painless. There we go. Hopefully those are painless. All right, let's keep going. Given that one face of a cube has an area of 25 centimeters squared, show your work. It didn't even tell us what it wants. They want us to find the surface area. So this cube has an area of 25, right? How many sides are there to a cube? Well, you might have assumed 6. 25 times 6 is 150. And now we are in centimeters, centimeters squared, so 150. All right, and then the volume of the cube, here's where we need to do a little bit of investigation work, right? So this is a cube, so these two dimensions are going to be the same. I know that my area is 25. Well, what times itself gives me 25? It's going to be 5. So the dimensions of my cube are going to be 5 by 5 by 5. So I'm going to multiply 5 times 5 times 5, or 5 to the third power, which equals 125. And we are in cubic centimeters now. There we go. Okay, so it says name the two prisms that will result from a cut in the direction shown on the prism below. So it says name the two prisms, not the two shapes. This is a very important distinction. Prisms are three-dimensional figures. So this top prism from this cut is in red. What type of prism is that? That is a triangular prism, right? The two bases are triangles. So we have a triangular prism on the top. And then on the bottom, I'm going to highlight this in purple. We have a shape that looks like this. Okay, you might notice that the bases are trapezoids, so we'll just call this a trapezoidal prism. If you want to just write trapezoid prism, that works too. Okay, the second question is, what new two-dimensional shape will result on the face formed by the cut? So now we're talking about the flat two-dimensional shape. So if I were to slice this triangular prism where it says it's slicing, what shape can you expect to be on the face? Well, hopefully you guys said a rectangle. Okay, let's take a look at number 6. At the right are scale drawings of two cylinders. Cylinder 1 has a diameter of 8 centimeters and a height of 4. Cylinder 2 has a diameter of 4 centimeters and a height of 8 centimeters. It says to find the surface area of each cylinder, and we're going to show all of our work. So here we need to revisit how to find the surface area of a cylinder. So the surface area of a cylinder, so this is going to be equal to, we said we take the area of the circle and you multiply it by 2, right? Because there are two circles, the top and the bottom. Then you're going to add that to your, you're going to add that to your height and multiply that by your circumference. And that should give you your surface area, okay? So got a little bit of work to do. The area of the circle, let's start with cylinder 1. The diameter is 8, which means that the radius is 4 and the height is also 4. So let's find the area. Pi times r squared. So pi times 4 squared, which is 16, so 16 times pi. Let's go ahead and find the circumference as well, which is pi times your diameter, which is 8, so 8 times pi. And we're going to multiply 8 pi times the height. In other words, we'll get 32 times pi. So we're going to do 32 times pi plus 16 times pi. Right, so I'm taking the area of my circle. Whoops, I forgot to multiply my area by 2. So hold on. So I need to multiply this by 2. So 16 times 2 is 32. So we have 32 pi. So I'm adding 32 pi, 32 pi plus 32 pi. 32 plus 32 gives you 64 pi. And so now we can type this into our calculator here. 64 times pi. So I get a surface area of approximately 201.06. And we are in centimeters, so centimeters squared. All right, let's go ahead and work with cylinder 2. So cylinder 2, the diameter is 4, which means that the radius is 2, and the height of this cylinder is 8. Okay, so again, starting out with the area. Area is equal to pi times r squared, so 2 squared. So our area of one circle is going to be around 4 times pi. And I'm going to multiply this by 2 because there are 2 circles, so I have 8 pi for the area of my circle plus times 2. And then now I'm going to find my circumference, which is pi times the diameter, or just 4 times pi. And then I multiply my circumference by the height, which is 32 pi. So now that I have the area of my circle times 2 and I have my height times circumference, I'm going to add these two together for a total of 40 pi. So you're going to type that into your calculator, 40 times pi. And you get approximately 125.66 centimeters squared. Do the cylinders have the same volume? Show how you arrived at your answer. So, yay, less calculations here, but the volume of a cylinder is pi r squared times h. So, continuing this separation here. Okay, cylinder 1, we're going to take the radius of 4, so pi times 4 squared, and then we're going to multiply that by 4. So you'll see 4 squared is 16 times another 4 is 64. So 64 times pi, which is approximately 201.06. And we are now in cubic centimeters. Isn't that strange how the surface area of the cylinder is also its volume? All right, cylinder 2, we're going to take the radius, which is 2, so pi times 2 squared, and multiply that by the height. 2 squared is 4, 4 times 8 is 32, so we have 32 pi. So 32 times pi gives you about 100.53. And we're in cubic centimeters. All right. Whew. Let me double check my work here. I just want to make sure that my surface area is good. So 4 squared is 16. 16 times 2 is 32 pi. Okay. Yep. Nope. These are good. All right. So here we go. The last problem on this page, it says the figure below is a sketch of a conical delivery system for a new satellite. Find the volume of the delivery system. So you might have noticed that I have a cone stacked on top of a cylinder. So we're going to split this. This is what we call a composite figure here. We're going to split this composite figure into parts that we know how to find the volume of. So you definitely know how to find the volume of this cone section right here. So in orange. So the volume of a cone, which we covered today, is 1/3 pi times r squared times h. Well, let's see. Do they give us all the things that we need? H is definitely 6. Do they give us a radius? They give us the diameter of the of the cylinder there, so we just take half of that, so our radius is going to be 4.5. So I'm going to substitute those values into my formula here, 4.5 squared, and multiply that by 6. 4.5 squared, right? It helps to kind of write out these steps here. So 20.25, and then we're going to multiply it by 6. So now I'm at 1/3 times pi times 121.5. Okay, so I'm going to do 121.5. I'm going to multiply that by pi. And then to multiply by 1/3, which is the same as dividing by 3. So the volume of the cone is approximately 127.23 cubic feet. Okay, so there's the volume of the cone. Now we need to find the volume of the cylinder, which is just pi times the radius squared times h. Okay, so do we have all of those things? Yes, the height is 6, the radius is again 4.5. So let's go ahead and substitute those values in. Pi times 4.5 squared times 6. 4.5 squared we said was 20.25. And then we're multiplying that by pi. So let's go back. 20.25 times 6 gives you 121.5. So we're going to do 121.5 times pi. And that's going to give us approximately 381.70 cubic feet. Now at the very end, to find the volume of the entire thing, you're just going to add these two together. For the sake of ease, I think we're just going to add our rounded values together. So 381.7, and we're going to add 127.23. So that's 3, 9, 8, 10, and 5. So for a total volume of approximately 508.93 cubic feet. And there we go. So that is your study guide. If you guys have any questions, please feel free to contact me, preferably not on the day of the test, okay? So before the test. All right, happy studying, you guys. I'll see you in the next class.